Taking a photo seems like a pretty easy thing to do, especially in the age we live in today. Simply pull out your phone, allow it to focus itself, and press a button. But have you ever wondered more about the process of how it got to be this way, or about what is actually occurring on a more scientific and mathematical level? Today, I'm here to reveal all of this information, and hopefully by the end of this video, you will be able to create your own camera and photographs out of literally anything. Welcome back to another video, Photos by Jem, here again to tell you really my journey for these past 2 months. So in 2015, my uncle sent me a book about turning any container into a pinhole camera. I've always found this topic to be quite fascinating and frankly unbelievable. As you guys know, I love photography, especially learning about photography from long ago, where it combined mechanics, optics, and chemistry, and required the photographer to consider how everything was going to work together. Now, I was able to recreate this age-old process by developing my own pinhole cameras. My goal was to develop one pinhole viewer to get more comfortable with the technology before jumping right in, one photographic paper pinhole camera, and one photographic film pinhole camera, taking actual photos with both, and finally a bunch of photograms. I'll begin by discussing my creation process, and later on in the video, I'll get into the specifics about the history and science of this technology. Let's start with the pinhole viewer. With a pinhole viewer, I was still able to see a real image through a pinhole, just not record it. Using a Pringles chip can, I measured up 2 inches from the bottom, cutting across the circumference of the cylinder. Later on in this video, I'll go into greater depth as to how I got this measurement with a specific equation. The next part required patience. Using an extra fine beading needle, I punctured a tiny, smooth hole in the metal bottom. I then taped down a circle of wax paper over the top of the short part that was cut out, which acted as my film or photographic paper. Finally, I reattached the 2 parts together, wrapped the can in aluminum foil and black tape, and rolled a piece of black construction paper into the can. This was required as a pinhole viewer or camera must be completely light tight, other than light coming in through the pinhole. I was thrilled to see it work. First, I used it to look at the sun. An interesting fact, a pinhole camera can actually make it possible to view an eclipse. Later on, I used it to see more clearly how a pinhole camera reverses an image when looking at my hands with it. Next, I made photograms, which are photographic images made without a camera. Basically, photographic paper has special properties where if light contacts it, it turns black. On the left is a piece that was exposed to light and developed. On the right is a piece that was not exposed to light and developed. If objects are placed on top of the paper, followed by the paper being very quickly exposed to light, the paper creates outlines of these objects after being developed as a result of shadows blocking light. For this to work, I turned my bathroom into a dark room, taping the door for absolutely no light to enter. Luckily, I had a red light bulb to see, which does not affect the paper as it has a small wavelength. I made my own developer solution as well as a stopper solution with water and apple cider vinegar to stop the developing. For each paper, I placed various objects on top, shined the flashlight onto the paper for about a second, and immediately placed the paper into developer for 2 minutes. Then I moved it into stopper for 30 seconds and finally let it sit in distilled water where I was finally able to turn on the lights. It was truly an awesome experience and left me with images to remember. Finally, I created my pinhole cameras. I first made one out of photographic paper, as I already had the solution for development ready. I spray painted the inside of a Quaker Oats container black and taped the top to make it light tight. Then I sanded heavyweight aluminum to make it thin, measured a 1/4 by 1/4 inch square, cut it out, and made my pinhole with a pencil pinhole drill, only allowing the very tip of the needle to pass through the metal. I continued with more precise calculations and measurements to make my shutter, holder, and shutter. Finally, I taped around the pinhole in order to reduce shine from metal and placed the pinhole inside. Voila! I created a camera out of a container. I tested it out by opening the shutter for about 40 seconds to take 2 pictures with it, one of my house and one of my mom. Comparing these photos with photos of the same scenes with my digital camera, obviously I could not get photographic paper to be in color, but overall it gives a sort of dreamy feel. If you look very closely, you can actually see how the image is reversed for the pinhole photographs. I did a very similar process to make a film pinhole camera out of a matchbox. This one required more work as the measurements needed to be perfect to fit the film. The main difference was that I could take multiple photos at once with this one, as I'd set it up so that I could roll film into an empty cartridge. Unfortunately, these were not developed in time due to COVID-19 causing delays, but these would also provide me with a somewhat blurry reverse image for a very unique look. In many ways, the pinhole camera was more fun to use than a digital one, as it took more than just the push of a button to create. Now, let's dig deeper into some of the history behind pinhole photography. The first cameras did not actually yield permanent images. They were used to study optics, similar to my pinhole viewer. Nomadic tribes of North Africa are thought to have been the first people to use pinhole technology thousands of years ago. Chinese scholars had discovered that light travels in straight lines in 5th century BC. Even Aristotle is part of pinhole history, as he wrote about pinhole images in the 4th century BC, describing the technology, quote, "Here the figures, here the colors, here all the images of every part of the universe are contracted to a point. Oh, what a point is so marvelous." The first person to study how humans see was Arab scholar Al-Haytham, who invented the camera obscura, which was the first pinhole camera created. It wasn't until the mid-1600s until lenses were invented. Artists began to use the camera obscura for assistance with perspective for drawings and paintings of real-world images. The camera obscura even led to the inspiration of the first projectors, or at the time what were known as magic lanterns. Using the camera obscura, French scientist Joseph Niepce developed the first photographic image in 1827. He created heliographs, or sunprints, by placing a metal plate coated in bitumen and exposed to light in a solvent, ultimately forming a photographic image made directly by the action of light. That said, this image would fade away relatively quickly, creating a new goal to be able to fix an image or make it permanent. Louis Daguerre of France was the first to create an image that did not disappear. Some years later, he utilized various chemicals and light combinations to create a lasting image that would remain the same after being exposed to light. Henry Fox Talbot, an English botanist and mathematician, was the first to create multiple prints of the same image, known as negative images, with the background of each image being black and the object or subject being rendered in gradations of gray. For years and years, this process kept improving with different chemical combinations, eventually leading to positive images that could be fixed or stored for a period of time in 1871. So why did pinhole photography matter? Well, for one thing, pinhole cameras proved valuable after the father of archaeology in the 1880s, Englishman Flinders Petrie, along with other scientists, incorporated pinhole photography during their research. This allowed everyone to be able to see what they saw, adding more proof and validity to their claims. Even more recently, although technology has advanced significantly in the world of photography, many high-technology industries such as NASA have special applications where lenses are not suitable and thus use sophisticated pinhole cameras to carry out these tasks. As the technology of photography and digital cameras continues to advance, it will forever be known that pinhole photography was the first major success in creating images of the world. Finally, how does the technology really work? In a pinhole camera, the pinhole is essentially the lens. Images are received on an image plane from being bounced off of an object and passing through an aperture or small hole. With the right-sized hole, the light will hit the image plane at very distinct locations, causing the tiny individual parts that make up the object to be reflected to only one point on the image. Light moves in straight lines, thus light rays passing through the hole at angles cause an upside-down image to form onto the film as a result. The perfect size of a pinhole can be very difficult to come by. While it is true that an image is sharper the smaller the pinhole is, it is also true that decreasing size of the pinhole leads to less light passing through and therefore increased dimness. The optimal radius of the pinhole is approximately equal to the square root of the product of the wavelength of the light and the distance between the pinhole and the film. Another key aspect of a pinhole camera's design is the distance between the pinhole and the film, and as well as the focal length. The thin lens equation states that the inverse of the distance between the lens and the film should be equal to the inverse of the lens's focal length minus the inverse of the distance to the object. These equations helped me in executing the precise measurements for my pinhole cameras. Essentially, what the math says is that the closer a person physically gets to an object, the greater the distance between the film and the pinhole should be to keep the optimal resolution of the photos. Overall, the process of pinhole photography is extremely tedious and precise, with every little measurement being important. However, getting one to work is an incredible, fun, and exhilarating experience, seeing a normal object turn into a workable camera. The sort of soft, dreamy, and timeless look that pinhole photos have will leave you with memories to keep forever.